Hello everyone. In this presentation we are going to see about one example program of 8085, that is addition program. Before going to write one addition program of 8085, just we can see the intro of microprocessor. Brief intro of microprocessor. In general, microprocessor executes instruction given by the user. The microprocessor understands only machine language of zeros and ones only. Then assembly language of 8085 use one word, that is mnemonics. That mnemonics convey the action and meaning of program. For example, move, add, sub. Move, that means indicate data transfer from one register to another register. Add, that is ADD, that is mnemonics, that add two values. Similarly, sub, that subtract two values. Using the mnemonics, we can subtract two values, two register values. So always microprocessor understand machine language only. But we are write a program using assembly language. Then after that we can convert it into machine language code through assembler program. Okay. This is the general programming model of 8085. In this programming model of 8085 has accumulator register, ALU, flag register, instruction decoder block, then memory pointer, then timing and control unit. This is the general register representation of 8085, that is accumulator register, B register, that can B register has 8 bit, D register has 8 bit, then H flag register, C register, E L register, then stack pointer register, program counter register. Okay. This is the overview of programming model of 8085. That means it has 6 general purpose registers, then accumulator register, flag register, program counter register, stack pointer register. Let us discuss one by one. 6 general purpose register, that means microprocessor 8085 has 6 general purpose register that is named as B, C, D, E, H, L. Also it can be combined as registered pairs, that is to perform 16-bit operations like BC, DE and HL. Okay. Then accumulator, this is an important one in our 808 microprocessor, 85 microprocessor, that is named as A, capital A. This register is part of ALU, that is store 8 bits. The accumulator store 8-bit value that performs arithmetic and logical operation. Always our result of operation is stored in this accumulator register. So that is indicated as capital A. Then flag register. 8085 has 5 flags, that is named as 0 flag, carry flag, sign flag, parity flag, auxiliary carry flag. This is also part of ALU. Then program counter register. This is a 16-bit memory pointer register. It is used to sequence the execution of program instruction. Sequence the execution of program instruction. The PC is incremented by 1. PC is now pointing to the address of next instruction. Used to this PC, we identify the next address of instruction. Then stack point register. This is also part of our 8085 microprocessor register. This is it has 16-bit memory pointer register. Then after next topic is instruction set of 8085. To write a assembly program using some instruction set in 8085. It generally consists 74 operation codes. Then 246 instructions we can follow while writing a program, assembly program of 8085. In general, 8085 instructions can be classified as data transfer, arithmetic, logical and bit manipulation, branch and machine control. Generally in 8085 follow 246 instruction. For example, move A comma B. Move immediate, that is MVI A comma 0 0. Like that we can follow 246 instruction in 8085 while writing assembly coding. So that is classified as 5 instruction set. Okay, that is data transfer, arithmetic, logical, bit manipulation, branch, then machine control instruction. Okay, then next our main part is how to write assembly language program in 8085. Before going to write one program, we can follow some steps. Okay, first we can analyze the given problem. Then next we can develop program logic. Then third step is to write algorithm of given problem. Then to make flowchart. Okay, after that write a program instruction using assembly language of 8085. This is those steps we can follow while writing assembly language program in 8085. Okay, so first we can identify that is analyze the problem from given statement. Okay, after that we develop logic, program logic. Then third step is algorithm, fourth step is flowchart, then finally write a program. Okay, this is the major steps to write a program. Okay, so in this presentation our objective is how to write addition program in 8085. Okay, so our statement given problem is to add two 8-bit numbers and store 8-bit result in register C. So what is the major steps to be followed while writing a 8085 program? First we can analyze the problem. Okay, that means what is our statement? To add two 8-bit numbers. That is the problem of our given statement. From given statement, that is addition of two 8-bit numbers to be done. Okay, this is the first step. Then next step is write a program logic. What is the main logic of this given problem? From given problem, to add two numbers. Okay, then that output of addition number is stored in register C. This is our program logic. Okay, for example, you take a register value, that is 99H. Then next register value is 39H. H means hexadecimal. Okay, then that value is stored in C register. Okay, this is our logic of given problem. Okay, from this logic we can develop algorithm. First step is we select two numbers. Okay, first to select two numbers, that is select two registers, that is D and E. That is store one value to one register, then second value is stored in E. Then in this algorithm, next step is add two register value. Then third step is store that value in C register. Then finally stop our program. This is the algorithm of the given statement. Okay. Then after that we develop flowchart. We make one flowchart. So already we know the how to develop a flowchart. Okay. Very first step is start. Then next step is load register D comma and E. Then copy D to A. That means our final value move to accumulator. Okay. Then add A and E value. Okay. Low for very start the flow chart. First step is start. Then after that next step of flow chart is load registers D and E. Okay, that means we add one value to D register, we load value to E register. Then next step of flowchart is copy D register value to A. Then we call add mnemonics, that is add instruction. Add A value and E value. That finally copy A to C register, that is accumulator value to C register. Then stop our program. This is the flowchart of given program or given problem. Okay. Then next we can write a assembly language program using instruction. Okay, using instruction. First get two numbers. The first step, you can see the right side of PPT. In this, first we use one mnemonics, that is MVI, that is move immediate. Okay. Then write D register comma 2H. 2H means hexadecimal. 2 value is immediately move to D register. So only we follow this mnemonics. Okay, here. Okay, this code is you can follow here. Okay. Then next step of this program is MVI, that is move immediate E comma 3H. That means there is E indicate destination, 3H indicate source. So 3 value is immediately move to E. So only we use there is MVI, move immediate. Okay. What is the next flow of our given statement? First we can select two register, that is D and E. Then load the value of some value to D and E register. So here we follow move immediate D comma 2H, move immediate E comma 3H. Okay. Now we load the some value in D register and E register. Then what is the next flow? Then always our final value is stored in accumulator. This concept is we know. So one register value is moved to accumulator. Okay, that is move A comma D. Move A comma D. That means D register value is copy the D register value to A, that is accumulator. So next, what is the next step of program is add E. Now we add the E register value to accumulator register. Always we write add. Automatically that we can write that instruction, the add E value to accumulator. Okay. So only we move the D register value to, in the third step of program is move A. If we can follow, we wrote move A comma D. That means our D value is moved to accumulator. Then next step of this program is add E, that is ADD, then space we write E. That means the accumulator value is added with E register value. Then store our value to C. Okay, this is our program logic. So in this we can write next step of our program is move C comma A, that it which indicate our accumulator value move to C register. Then finally we can write halt, that is HLT, just stop our program. Using this instruction we can stop our program. This is the addition program of two 8-bit numbers. Then finally our final reset value is stored in C register. This is our given statement. So based on our given statement we wrote program, okay, using some instruction of 8085. This is the assembly language code of 8085. Okay, this is the addition program of 8085. Okay, in general our instruction classified according to 8085 instruction set can be classified according to size, that is 1 byte instruction, 2 byte instruction, 3 byte instruction. Okay, that is 1 byte instruction. Example of 1 byte instructions are move C comma A. So move here is named as opcode. The first column represent opcode, then second column represent operand, then third column represent binary code of operand, then hexacode. Okay, then here we can follow, this is comes under 1 byte instruction, move C comma A, add B, halt. Those instructions comes under 1 byte instruction. Then 2 byte instruction, examples of 2 byte instruction. So similar, there is MVI, that is move immediate A comma 32H, that is it use 2 bytes. Okay, then example of 3 byte instruction. So another example of 3 byte instruction is LXI H comma 2050H. If suppose we can follow this type of instruction, means it occupy 3 hexacode, that is 3 address location. Okay, thank you.